You can stick it to the back of your laptop so that Gil and I can see, and that just knows that we should, either Gil should go over and help out, or I can stop the class if too many people need help. So I'm assuming that all of you have already done the pre-work of installing Git and installing a text editor, doing a couple other things. So I figure we can just get started. Oh, I also wanted to mention, I am in the process of writing a book with O'Reilly. I'm writing Headfirst Git. So if you like this tutorial, if you know other people who might be interested in learning this way, you can get the book when it comes out. Shameless plug. So how many of you have actually done version control of any sort in the past before? Raise your hand. Okay, so most people have done it. How many people have used Git specifically in the past before? Okay, fewer people. And I'm guessing that if you're here, you're not super confident with Git. Is there anybody who is super confident with Git? All right, that's what I thought. Cool. So I'm just going to start from the beginning in this tutorial. Even if you've already used version control before, even if you already know how it works, treat it as a good review. Especially because the way that Git approaches version control is in some ways a little bit different from how previous version control systems have done it. So I think we all know why version control is great. It allows you to go back to old versions and allows multiple editors to make lots of changes without stepping on each other's toes. So this is what a centralized version control system looks like. There's a central repository. Every individual editor has their own partial copy of the repository. It just has the latest changes and doesn't have all the historical work. This is what something like CVS or Subversion looks like. Then there's decentralized version control, and this is more like what Git looks like, or Mercurial or Fossil or some of the other distributed version control systems. The idea here is every single editor has a complete copy of the entire repository. There's no server or client per se. They're simply clones, and every single clone has the whole history, which you would think would be very intensive in terms of disk space for every single copy to contain the entire history. But Git is very, very good at packing these history fragments down very, very small, so that usually disk space is actually not a problem. So here's what we're going to go over in this class, or at least as much of it as we have time for, because as I said, there's a lot to go over, and I'm not sure if we're going to get through everything. You're going to learn how to make your own Git repository. You're going to learn how to collaborate with other people in this room, pushing and pulling commits and making pull requests to request that your changes get merged into other people's repositories. Then we're going to learn about Git's branching model and how to work with multiple branches, multiple changes simultaneously. Then we're going to learn about moving commits among a single repository from branch to branch and changing history in order to reorder commits in a repository. And that's where the whole travel through time business comes through. Rebase allows you to modify the history and rewrite it to something that's closer to what you intended rather than the actual 5 oops, I made a typo commits that most people make, including myself. So here's the basics. Let's get started. I'm going to ask you all to actually make a repository on your computer, and we're going to call this repository Cookbook, simply because cookbooks are a familiar metaphor for people exchanging information and making modifications as they go. Aunt Sarah's famous cookie recipe that actually I've modified a little bit by adding extra butter or whatever. So git init is the command to create an empty repository, and as the slide says, that's going to create a .git directory that stores all the repository information. So you should all pick a directory on your computer, doesn't matter where, and run git init cookbook. And you should see a message saying that it created an empty repository. Now, if you actually look inside of it, you'll see that there's this .git directory. And because it starts with a dot, it's a hidden file, so you'll have to use the ls-a command to see the .git directory. And if you look inside, there are a couple of files in there. This .git directory is the location of the commit history for Git. Most of the time, you never need to touch the contents of this directory. And there's one exception to that, and that is the config file. The config file is very useful. It's a plain text file. It's in the INI format. So if you want to open that up in a text editor and take a look at how it looks and how it works, we're going to do that during the tutorial. Everything else in here, you can take a look at. You're not going to damage anything by looking at it. but particularly things in the info, objects, and refs directory you probably don't want to modify directly because that's where Git actually stores the commit history. But one of the nice things about Git is it's just implemented using Unix tools, and it uses a lot of plain text format. So you can explore how it all works. So the first command we're going to use to modify a repository, because we've already learned one command, that's git init. Now we're going to learn git config, which actually most of you have already used in the pre-work to set up your text editor to work properly with Git. So git config allows you to read and write values to Git's configuration files. And there are actually several files. So there's one configuration file within the .git directory, and you also have a global configuration file which lives in your home directory, and that one's called .git config. So you can use the -- global flag to read and write from the global .git config file in your home directory, or by default, it's just going to use the one that's in the repository. So every time you make a commit, Git stores information about who made that commit, the name and the email address of the author of that change. So it's not going to allow you to create new commits until you've set that information at least once. And because that's not going to change from repository to repository, most people suggest that you use the -- global flag in order to set it once in your .git config file in your home directory. So you can run these commands, and if you want to, you can actually open up the .git config file in your home directory and see the changes that you're making to that file. You can even, if you prefer, you can just modify that file directly in your text editor. And then if you run git config user.name without providing a value, that allows you to read the value from the config file. And you'll see that modifying the file directly allows you to modify the value that's returned when you run git config user.name or whatever you'd like. So it's pretty straightforward. It's all plain text. Not super scary. So the next thing we're going to do is going to make a file for our repository that we've just created. So again, we're making oh, sorry.
Are we supposed to set both of those, or just set either one?
You're going to need to set both of them. You can also, try only setting one and moving on, and when you make a commit, Git will say, I can't make this commit unless you tell me who you are. You can also put the little sticky note on the back of your monitor if you're having problems rather than raising your hand. But
If you have non-English characters in a name, may it cause problem anywhere? Either Git locally or GitHub or somewhere else? Would that be a problem if they have non-English characters?
So I know that modern versions of Git have excellent support for Unicode characters. I don't actually know one way or the other about older versions of Git. I know that there is a setting that you have to set in order to make Unicode file names work properly on Mac OS X because the file system is all wonky or something like that. I believe that it will work just fine. If it doesn't work just fine, Gil will probably be able to help you out. Everybody else all set? Cool. So now we're just going to make a file in the repository. I've made an example file. You don't have to copy this whole content. This is just the idea. I'm making a recipe that I'm going to put into my repository. So you don't have to copy this whole thing. You can just put in some text if you want to. I just wanted to have some actual, somewhat meaningful content. So type in whatever you'd like. Save it as a file that lives in the cookbook folder that you've just created. And after you've created a file and saved it, then we're going to learn a new Git command, which is git status. This is probably my favorite Git command, because this is the command that tells me what the heck is going on. And it's a command that never will modify anything, never will break anything. It just gives you further information, and sometimes can give you suggestions about what you want to do next. So if you run git status, it should tell you that there is an untracked file in the repository, and it will ask you if you want to add it. So actually what I'm going to do is I'm just going to run some of these commands myself. So I'm going to go to my clones directory. I'm going to do git init cookbook. All right, nothing in there. I'm going to go back here, copy this whole thing. All right, so now I have my cookbook folder that has s'mores.txt in there. And if I do git status, you should see something like this. So there's one untracked file here. It says, I see this file, I don't know what you want me to do with it. And the reason why it does that is because Git is intelligent enough to know that just because a file lives in the repository directory doesn't necessarily mean that you want it committed to the repository. An example of that is, let's say you're doing some documentation and you have a markdown file and you render that markdown to HTML. You probably want to save the markdown file in your repository, but you don't necessarily want to save the generated HTML. Or if you're programming in Java or something like that, and you end up with class files, or Python and .pyc files, there are some files that end up getting generated that you don't necessarily want to stick around. So Git's going to ask you, I see this file, what do you want me to do with it, before doing anything automatically. So, yeah, that would help. Yes, thank you. So I am in my cookbook directory right here, which actually you can see in my shell because I'm using ZSH, and it has that by default in the theme that I have. So you're going to want to make that file inside of your cookbook directory. And again, the content doesn't matter so much. You can type in hello world if you want to. I just wanted to use some content that sort of made sense for a real world scenario.
So the git commands only work if you're inside your working project?
Yes. Every time you run a git command, it's going to run in the context of whatever repository you are currently inside of. Did you have a question? Okay. All right, I'm going to keep on going. And if there are too many people who have too many questions, then I'll pause to make sure that everybody gets their questions answered. All right, so I have created this s'mores.txt file. The next thing I want to do is I want to use git add. And you can see that status is actually suggesting you probably want to use git add to include it in what will be committed. So I'm going to do that right now. I'm going to say git add s'mores.txt. And it's not going to tell me anything has changed. No output typically means everything's good in the Unix world. So now, if I run git status again, it's going to tell me something slightly different. It says there's still a new file, but now it's under the heading changes to be committed. And it's going to suggest if this was an accident, if you didn't actually mean to add this file, you can use the command git rm -- cached file to, it's called unstage it, to make it so that it is no longer all set to be committed in the future. So let me go back to the presentation. So git add is what we just did. The nice thing about add is you don't have to just add files one at a time. You can add directories as well. And when you add a directory, it's going to recursively operate on every file in that directory, and every file in every directory in that directory, and so on. So if you have a lot of changes in your Git repository and you want to add all of them at once, you can just do git add period, because period is a reference to the current directory that you're sitting in. So that'll say, just recurse on down through these directories, find every file, any change that I've made, add that so that it's ready to be committed when I do the actual commit. In addition, every time you run git add, what it does is it looks at the file as it is at that point in time, and it stages it for commit. It says, at this point in time, this is how it's going to be when it commits. If you make further modifications to that file after running git add, Git will not automatically pick up those changes. When you say git add, you are telling Git, I want this file as it is at this point in time to be sort of the frame for when I form a commit. So that allows you to make further experimentation in the files and not have Git automatically pick up any changes that you didn't intend to be committed. So Git has this interesting thing where you set up the commit before you make the commit. And then the last step in making making a commit is running the git commit command. Now this is going to ask you for a commit message. And if you've set up your text editor correctly, Git will actually open your text editor with a file saying, please type in a commit message. So I'm going to show you how this works.
May I ask a question about
Yeah.
git add?
Mm-hmm.
I perform a git add and I have a file in a certain state. I make some changes. That doesn't impact the git add that I just did.
Correct.
But I want to update that add. I decided that's good.
Mm-hmm.
If I perform another git add, it does the latest.
Exactly.
Checkpoints it.
Yeah, exactly. So now what I'm going to do is I'm going to run git commit, and it's going to open up my text editor. And I'm not sure how easy it is to see, but it actually gives you a helpful little comment here saying, please enter the commit message for your changes. Lines starting with hash will be ignored, and an empty message aborts the commit. And it'll also tell you which files you are getting ready to commit. So if you have accidentally added something that you didn't intend, or if you're missing something that you intended to add, this message will actually give you a little bit of a heads up there. Now, like any version control system, Git requires you to make commit messages for your commits. And Git has a couple of nice tools that allow you to explore the history of your repository. And some of those tools assume that your commit message is formatted in a certain way in order to make it easier to read. And that way is you have a short title line here, followed by an empty line, followed by a longer description of your change. So the idea behind this format is that if someone just wants to get a very quick overview of the change that you're making, they can just read the first line of the commit. And if they're confused or if they want further information about why you're making that change, then they can read the longer description of your commit. But if you just want to get an overview, you can just use the first line of the commit message. This is not something that's built into Git per se. This is just a convention. This is best practice in terms of writing commit messages.
Your text opens in your text editor, but mine opens in Fly. Is there a way to have it edit in text editor?
Yes, that was something that I went into in the pre-work. If you use the git config editor command, I think it's core.editor, then you can set up whatever text editor you want for Git. So I'm using Atom, but you can use Sublime Text, you can use Vim, you can use Emacs, you can use any plain text editor you want as long as it has shell integration.
Is there an easy way to put a regular expression enforcement on your commit comments, such as like if you want to make sure somebody put in a ticket number and it's a certain pattern?
There is an easy way to do that, but I was planning on getting to that sort of thing at the very end of the presentation because it's not sort of core to Git itself. But if I don't get time to get to that, then come and talk to me afterwards. I'm happy to help you out with that. But the answer is yes, absolutely.
You don't end the messages because of the period of anything. You have no period at the end of the sentence.
That is something that's sort of up to the individual team. Some people care more about sentences and grammar and formatting than others. The thing that most people care about in terms of writing commit messages is this general format of a title followed by an empty space followed by whatever else you want. So that's up to you. Or rather, I should say it's up to you and your team of whoever you're working with using Git. So in this case, I'm going to just say this is my initial commit in the repository. And I'm going to leave off the extended description because there's not a whole lot to describe. And I'm going to save it and close this. And then this says, OK, great. So you have made a commit. It's going to show me that first line of the commit message that I was doing before. And it's going to confirm for me you made one file changed. And it's going to tell me which files are created as well. So now we have this commit. Awesome. Let me go back to my presentation. Oh, one other thing. If you are having problems with your text editor, or if you have a very short commit message that you want to create for your commit, and you don't want to bother opening up your text editor and closing it back down again, git commit actually has a -m flag that allows you to provide a message on the command line. So I could have done the same thing just by running git commit -m quotation mark initial commit quotation mark. So this is just like a shortcut or an optimization. It's something that you should only use with commits that are relatively small, where you don't really care about providing an extended description. But in those cases, when you just want to sort of get through the process of making a commit, -m is a useful flag to use. You can also use -- message, same thing. So we've gone over how to create a change in the repository. You edit the files and save them. You do git add to add the files to your upcoming commit. And then you run git commit. And git rm is another command that's sort of like a special case of git add. It's used to remove a file from your repository. In fact, let me show you something interesting here. If I run git status right now, it's going to say there's no changes. If I want to remove the file that I've done using the normal rm, then it'll let me do that, of course. But Git says, you have made changes that are not staged for commit. So you've deleted this file, but I'm not actually doing anything to say that you intended to delete this file. And if I try to run git add s'mores.txt, then that works. But you can also use git rm to do the deletion and indicate that that was intentional in one change, in one command. Yes. Sorry. So,
you deleted the file from the directory.
mm-hmm.
Git add deleted it from the repository.
Git add is the thing that says the upcoming commit should match the current state of my file system. So when I said git add s'mores.txt, Git knew that there was a file called s'mores.txt in the repository previously, looked at the file system, saw that that file was no longer there, and said, oh, that means he must have intended to get rid of it. You can also do the same thing by running git rm followed by the file name. Exactly the same thing. I actually wasn't sure that git add followed by a path that no longer existed would work. Turns out it works. I learned something today. Yep. When you add a directory, it's going to add all of the files inside of that directory. And it's going to recurse downward. So if there are more directories with more files inside of those, then it's going to add all of those as well. All right. So rm is basically a special case of add in Git terminology. So, quick bit of review. Here are the commands we've learned so far. git init to create a repository, git status to check on things, git add to add a file to the repository, or to update the current status of that file in the upcoming commit. Git rm is a special case of git add to just delete a file and tell Git, yes, I intended to delete it. And git commit is the thing that says, all right, now this commit is all ready to go. I'm going to actually create it and provide a message.
Probably the best way is the alias git status to be st.
Yep.
Saves some characters.
There are lots of different aliases that you can set up. I'm not going to go into that right now because I'm just teaching vanilla Git. But again, that's something we can go into at the end if there's time. Also, as long as we're here at sort of a checkpoint, there was something I was supposed to read at the start of this tutorial, and I apologize. I wanted to let everybody know that there is a survey link for your tutorial located on the back page and also available in the Guidebook mobile app. The AM break will be at 10 o'clock today, which is in about half an hour, in the lobby outside of this room. Lunch will be at 12:20 p.m. in the Oregon Ballroom 201-204, which is upstairs. At lunch, those with dietary needs should let a server know. And we have placed as much power as we could afford. Please share the outlets. Outlets could be in your row, in the row behind you, or in the row in front of you. So I'm sorry, I should have done that at the beginning, but totally didn't. My bad. Anyway, this is what we know so far. So now we're going to go into viewing these commits that we've created. So git log is a great way of doing that. Git log is going to display a log of all the commits, and you can use the arrow keys to scroll. So let me show you how that works. So here is the one commit that I have made so far. And as you can see, it already has the information about my name and my email address, which I had set previously using git config. That's in my global.gitconfig file. And at the top, there's this line that says commit, followed by this long string of letters and numbers. That's called a commit hash. And we're going to get to that in a little bit. I don't want to get into details right now, but basically it's an identifier for a commit. So if you have a lot of commits in here, you can scroll using the arrow keys. And when you're done, you can press Q to quit. Because you're just using whatever pager you've set up with on your system. The default pager is called less, and those are the controls for less. Up and down arrows to scroll, Q to quit. You can also use git show to show detailed information about a particular commit. So now what I'm going to do is I'm going to use git show without any arguments, and it's going to show me the full details of the most recent commit. If you don't provide any arguments to git show, it's going to default to whatever is the commit you are currently sitting on right now. So in this case, the most recent commit in the repository. And as I said, you can use the arrow keys to scroll up and down. And oh, I have some Unicode characters in here that I wasn't expecting. That's cool. So now, what happens if you have multiple commits? So I'm going to open up this project in my text editor. Assuming that that works, there it is. Oh, this is like tiny. Oh, because I removed the file, of course. So I'm going to unstage this change where I had deleted s'mores.txt. I'm going to do git reset head s'mores.txt, just as I see right up here. And we're going to learn more about the reset command later. So now it says that file has been deleted but is no longer staged for commit. So I want to discard these changes, because the changes is me deleting the file. So I can do git checkout -- s'mores.txt. Now git status said there's no changes, and hey, my file's back. That's what I was looking for. And this is really tiny. All right. So I'm going to make a change here, I'm actually going to add another new recipe. I'll call this salad recipe. I'll leave it misspelled. All right, and I will save this file as salad.txt. There it is. I'll add it. And I'm going to use the M flag because I don't really want to open a new Atom window. There we go. So I've made a new commit. What doesn't work? I was just following this direction here that git status was telling me. So that's going to say, take whatever file you have modified and that you've already added, and essentially unadd it. Make it so you had never run git add. And then the second thing down here, now that the change was unstaged, I used git checkout -- file to get rid of whatever changes I had made. So that brings it back to the status of that file at the latest commit in the repository. So I was basically just going backwards, undoing my steps. And I was doing that by running git status at every point. And it helpfully tells me, if you want to undo, this is the command you can run. So that's all that I was doing there. So now I have two commits. I have my initial commit, and I have my second commit where I added a salad recipe. And you can see that each of these has a different commit hash. That is the long string of letters and numbers across the top that's highlighted in green. The commit hash is a number that is calculated based on the contents of a commit, the person who made the commit, the name and email address, and the time that that commit was made, as well as whatever parents that commit might have. So it looks random. It's actually not. It is a number that is calculated based on several different factors. And because of the way that it's calculated, every commit is going to be different. Every commit hash is going to be different, I should say. The chances of two different commits generating the same commit hash, having a collision there, is there's more atoms in the universe than there are possibilities where that could. There's some metaphor here involving atoms in the universe that is flying out of my head right now, but suffice it to say, it's very, very, very unlikely. So we can use these unique strings of letters and numbers as identifiers for commits. What? Mm-hmm. Yes. Yes. But you can always create a new commit based on the old commit to update the timestamp. And there are tools that will allow you to do that, which we'll get into later. The timestamp is not super important for hyper accuracy. It's just, oh, you made this commit on this day, which is helpful for remembering the sequence of history for when things happened. So at this point, if I do git show, it's going to show me the details for the most recent commit that I've made. However, if I want to get back to the previous commit that I had, let's say I want to see more details about this commit over here. What I can do is I can copy this commit hash, and I can run git show followed by that hash. And it's going to show me information about that commit. So you can do that with any commit you want to in your repository. Take the hash, copy it, paste it in. Sure. So you can use git log to get a history of all the commits in your repository, starting from where you are and moving backwards in time. If you see a particular commit that you want to get more information about, such as the actual change in that commit, you can grab the commit hash. I'm copying it to my clipboard. And then you run git show followed by the commit hash. Just paste it in. And that will show you further information about that particular commit. That's true. One of the nice things about Git in terms of references is there are many different ways to reference the same commit. And the full commit hash is certainly one way of doing so, but you can also use what's called a short commit hash. So you can just use the first few characters. If I do git show 17b16, enter, it knows the exact commit that I'm referring to. Exactly. So you provide the first few characters, and Git will check all the commit hashes that it knows about that starts with those characters, and if there's only one, it knows that's the one you mean. If there's multiple commits in the repository that start with the characters you specified, it will just say, I don't know what you mean, you need to provide more information, and it won't do anything. It'll error out. But even in very, very large repositories, typically the first 7 or 8 characters of a commit hash is plenty to uniquely identify it. I believe in the repository for the Linux kernel, which is the system that Git was invented to manage, that has billions of commits, you still only need 8 or 9 characters to uniquely identify any particular commit in there. All right. So git show allows you to get detailed information about a commit. Git diff is also a very useful command. Now, we saw in git show that it would actually provide an output of the exact changes that were in that commit. If you want to get the same sort of output before you've made a commit, that's what git diff is for. It's going to show you the changes between the last commit and the files that are on disk that you haven't yet run git add on. So let me give you an example of this. Oops. Over in here, I misspelled ingredients. So I'm just going to correct that, run save. And now, if I run git diff, this is the diff that I have of the changes on disk compared to the last commit. Git diff is a great way of doing a quick sanity check to say, have I actually made all the changes that I want to make? And have I made any changes that I don't intend to make? As a real-world example, when I'm developing Python code and I'm trying to debug something, I will often stick in PDB breakpoints, and then I will use that to debug what's going on, and then once I've solved the problem, then I'm ready to commit. But I don't want to commit PDB into the repository, so I will check git diff to see, oh, are there any lines where I added the PDB breakpoint before committing them? So you can also see that the way that Git handles changes in a line is it just treats it as the old line was removed and the new line was added. I think that's pretty standard among version control. It's just line-by-line version control. So now, if I do git status, I can see, OK, it's salad.txt that was modified. Git add salad. And now, if I do git diff, it's going to show me nothing. Because by default, git diff is only going to show you the changes that you haven't yet added. It's assuming that any changes you've already added, you've already verified that it's all good. So it's only going to show you the things that you haven't yet added, the things that you're still wondering, should I add this or not? If you want to see the things that you've added, you can do staged, git diff -- staged. And that will show you only the changes that have already been added for commit and not yet committed. But the default is just show me changes on the file system that haven't yet been added to Git.
The syntax here, it looks like the line was taken out, the green line was added. And I'm getting that even on lines that I just modified. And that's normal?
Yes, because Git, like most version control systems, treats the smallest level that you can modify as a line in a file. So if you've modified a line, Git isn't going to see exactly what part of the line you've modified. It's just going to see, oh, the old one was taken out and the new version was put in. It does.
So if you put a bunch of inners in, you'd see a bunch of plus green
hmm
blanks, right?
In fact, I can show you that right now. I'm going to add some extra white space after a tomato. And you can see it's only showing me the white space. It's not showing me the change I made to the ingredients header because I'm running git diff without the -- staged argument. So it's only showing me the changes I have not yet staged. And by contrast, if I run this with staged again, it's only going to show me the changes that I have staged. The staged is changes that you have already run git add on. The term in Git is the staging area. When you run git add, you are taking the changes in files and you are moving them into the staging area. And then when you run git commit, you are taking the changes from the staging area and you are moving them into a commit.
So if you do a git add on a file you changed, and then you modify it some more before you commit it, you do another git add on that same file.
Yes, you can. So that's actually the state that I'm in right now. I've made one change, I've added it, I've made a separate change. Now, if I run git status, it's going to list that same file in two locations. It's going to say there are changes that are ready to be committed, and there are changes that are not staged for commit. And it's giving me these little helper things saying you can use git reset head to get rid of the changes you've already staged, or you can use git add to update what will be committed. So I'm going to do that now. Now if I run git status, it's just going to show me the one place. Git diff is going to show me nothing. And git diff staged is going to show me both.
What are the @ lines?
Are you talking about this line here?
Yeah.
That is, so everything from here on up is part of the unified diff format, which is separate from Git itself. It was defined before Git was invented. The @ signs are to indicate which lines in the file have been modified in this context. So this is saying the lines that we see here are lines 1 through 8 in the file. But depending on what changes you make and how you add lines to the file, delete lines from the file, and so on, those numbers might be different. So if you have a file of 100 lines and you have a change that you've made on line 53, Git might show you 3 lines of context on either side. So it might say 50 through 56 in order to show you line 53. But if you're removing, let's say, 10 lines from the file, if you just delete 10 lines, you're going from a 100-line file on one side of the change to a 90-line file on the other side of the change. And that's why there are 2 sets of numbers here. Because when you change the number of lines in the file, the context lines might change as well. So in this case, they're just repeated, because we're not adding lines, we're not removing lines. But that's why there's 2 copies of it. And you can look up more information about the unified diff format by doing, I think it's man diff. Diff is a separate file utility. So there's, yeah. Sure. So there's lots more documentation out there on the internet about that format. I don't know all the details, but that's the gist of it. Any other questions about git diff?
I'm still a little fuzzy on that stage area. So when you do an add, when you do an add, it puts it in the stage area, and you do a commit. And all that's really doing is behind the scenes, it's putting it in that .git directory.
Exactly, yeah. So the staging area and even like the commit area, they are real places on your computer's disk. They live in the .git directory. I would encourage you to think of them as imaginary places, just because trying to go through all of the mental gymnastics of saying, okay, so this file gets hashed, and then this part of it gets put over here, and this part gets put over there, not worth it. So.
Once you add a file, that's considered tracked for source control purposes, and then you can only the only meaningful thing
Yes.
or RM.
Mm-hmm. Yep.
You're saying not only delete the file off of my physical part of my disk that's not in source control, but also consider it removed from that staging area.
Exactly.
Now, is it online at the point where you committed?
None of this is online at this point. All of this is maintained just on my own repository, on my own computer, rather. And I'm going to get to the part where we share these repositories online so that everybody can collaborate with each other in this room. But I'm going to get to that in a little bit. And the answer to your question is no. You can't push something to a different repository unless it's actually in a commit. Staging area is not something that will get pushed from repo to repo.
That's a really good point, because that's how fundamentally this differs from like Subversion or serial source control.
Yes,
Like your only concept of commit, there's no local commit, it's commit to the
that's right.
source or where. This one now we're gonna take these final repositories and you'll do it later, branch,
Exactly.
hop from branch to branch.
Yeah. So that's why I wanted to go over version control from the beginning in this, because Git treats version control differently from a centralized version control system. You have the entire repository on your own computer, and you never need to share it with anybody else if you don't want to. You can do your own version control with your own repository and history, all maintained in one clone, as it's called, one repository.
One more quick question, this reset head,
Mhm.
go through that one more time.
I haven't really talked about the reset command. It's used to modify files and modify branches in Git to point to different places. So in this case, we're simply saying, take this file reference, reset the contents on disk to as that file exists at head, which is a reference to the most recent commit. But again, that's dealing with a couple of concepts we haven't really got into yet. I'm trying to gloss over it a little bit.
Can you elaborate a bit on the advantages of staging? I'm using Mercurial. It's also distributed. There's no staging area. It works just fine. You just add it and then you commit it. But now you have an extra step, which is kind of seems like extra work to me. What are the advantages of staging?
So a lot of people do make that comment of this whole git add thing feels like extra work. I would make two replies to that. The first is, in my experience, it's actually not, because I often find myself working on more than one thing at a time unintentionally. I'm trying to add a new feature, and in the process, I fix a bug that I need to do in order to do that feature. So using git add allows me to separate that into two separate commits, one commit to fix the bug, and a second commit to add the feature. So that can be useful. And the second point I would add is, if you really, 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 really don't like having to run git add, there is a flag that you can pass to git commit, which is git commit -a. And that basically says, take all of the changes that have changed on disk, even the ones I haven't added, and commit all of them all in one go. So if you really want to skip that, you can just go directly to git commit -a. But I don't recommend it. I like the staging area, and it has made my life significantly easier several times over. So that's up to you.
Can you just list the file names or say commit just the straight file names?
No. If you want to do that, then you have to use git add ahead of time.
One last
Mhm.
question. So git commit will bring up the text editor
Yes.
so that you can add the comment.
Mhm.
Git commit as the command doesn't return until you exit the text editor.
That is going to depend on which text editor you use. So if I do git config core.editor, you can see that the command that git is using in this case is atom --wait. So I'm specifically configuring atom to not return until that file has been saved. And most text editors that you can run from the command line have a flag similar to this, specifically for Git or a similar system. So you have to configure that.
It seems you have to actually close the window before.
Yes. Yeah. So again, that's going to be up to your editor. All that Git does is it runs the command, waits for it to complete, and then uses whatever file on disk it asked it to edit. In a way, Git is actually remarkably simple. It's built on a lot of these standard Unix tools, and each individual part of it is not very intelligent. Like git add, all it does is it takes a file, adds it to the staging area. Nothing super complicated, nothing magic. Git commit, all it does is it takes the staging area and moves it to the commit. That's all. Nothing complicated, nothing magic. It's when people see how you can put all of these together that you get things that are complicated and confusing and magical. But when you break them all down into component parts, it becomes a lot easier to understand. All right. So we've been able to view our previous commits and view the changes in those commits. Now, if we want to actually view the state of the code or the state of the project as it was when that commit was made, that's what git checkout is for. So essentially, this is the command to travel back through time and view things without modifying them. So when you run git checkout, you need to pass it a reference to a particular commit, and it will take you back to that time when that commit was the latest one in the repository. Now, unfortunately, because Git is assuming that we know more already than we do, it's going to give us this big, scary detached head warning. So let me show you what that looks like. So if I do git log, and I'll say, here's the commit that I want to go back to, git checkout paste. Oh, and I need to get rid of my changes before I can do that. So I'm just going to git commit corrected spelling. Now I have 3 commits. But none of these commit hashes have changed. Git checkout paste. So this is that warning that I was talking about. You are in detached head state. It's really big. It's really scary. It's really harmless. And I don't know why Git makes this warning so big and scary. In a little while, after we handle all of the collaboration bits on GitHub, I'm going to go more into how branches work. But this is basically complaining you're not using a branch anymore. If you're familiar with version control, you probably already know what a branch is. If you're not, I'm going to get to that concept later. But yes, as big and as scary as this is, it's really just a warning. And it's really kind of unfortunate that Git makes it so scary. Anyway, now I'm back to the state before I had made any of those other commits. And s'mores.txt exists, but salad.txt does not. And if I run git log, then I only have the one commit, because I'm back at that state before I made the other commits. So you can always use this to go back in time. What if you want to go forward to go back to where you came from? So that is where branches come into play. And as I said, I don't want to get too deep into that right now. So for the time being, just run git checkout master. And we're going to treat that as magic for now. I'm going to come back to it. I don't want to get too deep into branching right now.
So essentially the situation you had is you had these 3 checkouts.
3 commits, yes.
3 commits. By doing the checkout, you went back in time to the one, but because they're just linear, there aren't any branches, you essentially reset the state to that place where you were when you started.
Exactly.
And then master just took you back to where you were.
Exactly.
Cool.
And now if you do git log, there are the commits again.
So is there anything you might have done that would have got rid of that final commit so that you could, is there anything you could do that makes it so you can't go back to master anymore, or is that always there?
That's always there. I think the question you're asking is, if you make a commit, is there any chance that you would lose that commit? And that is actually what this detached head state is warning you about. Once you're in a detached head state, it's warning you any commits that you make may be lost. So it says, if you want to create a new branch to retain the commits you create, you may do so. So that's what branching is all about. When you're in a detached head state, any commits that you make, you might not be able to get back to them. So if you run git checkout master, that's going to get you out of the detached head state and put you back on master. You can actually see ZSH here. When I did this, it switched my reference to a commit hash. And then when I did git checkout master, it switched my reference to master. So as long as you see master here or some other branch name, any commits you make will be attached to that branch. If you just see a sequence of letters and numbers, that means you're in a detached head state, and any commits you make might not be saved unless you know how to get back to them.
What was that command that got you there? Just scroll this a little bit.
Git checkout is the thing that allows you to jump from one commit to another.
Can you use a short hash?
Yes, you can. And to go back to the branch, you're just going to run git checkout master. And again, I'll explain branches more later. I don't want to get too deep into it right now. So you can use checkout to go back in time, view your code as it was at a certain point in time, and you can use checkout master to go back to where you were.
Just tell me if I'm asking too deep a question here, but if I look at the sequential check-ins,
Mm-hmm.
when I did that first command that got me into the detached head state, I'm just saying, hey, go get me a copy of everything my repository looked like at index X,
Mhm.
right? But the reason it's called detached head is because I haven't rewound everything to sync the staging in the file system to that point, right? When I actually run that last command, I chop off the head, literally, right?
That's not quite true. I'll get to that question a little bit later. All right, so now we'll do a little bit more review. We've learned a couple commands for viewing commits. We've got git log, which shows you the commits you've created in the past. Git show, which you can use to get more detailed information about a particular commit. Git diff, which is useful for sort of checking your changes, checking your work before you make a commit. And git checkout, which allows you to rewind back to a point in time, or with git checkout master to snap back to where you started, to snap back to the most recent commit. And these are the commands that we learned previously as well. So we've got 10 commands now. And we're starting to learn more and more about how to make commits and how to view them and manipulate them a little bit. Incidentally, I'm going to post all of these slides online. So you can and should take notes if it helps you to remember, but you can also have access to this whole presentation after we're done. Git has a lot of commands. So we're going to be coming back to this sort of view a couple more times in this presentation to review all the things we know. So anybody who has any questions about any of these commands and how they work? Cool. All right. It is about 10 o'clock, which means we have a break now. So if you all want to go outside, get some coffee, get some rest, something to drink, I'm going to start up again at 10:15. So I'll be here. All right, is this working? Can you all hear me well? Awesome. All right, so I'm going to get started again. So far, we've learned how to make commits on your computer, and we've learned how to view them. But really, the core part of Git, the thing that makes Git amazing, is the collaboration that it allows you to have with other people. So now, we're going to go into a new section about sharing commits across repositories. And this is the part of the tutorial where we're going to use GitHub, and all of you are going to collaborate with each other and with me. So make sure that you have an internet connection on your computer as well, because otherwise you won't be able to reach GitHub. So you should all already have a profile on github.com. You should be able to log in, and what we're going to do is we're going to create a new repository on GitHub, and we're going to push the contents of each of our cookbook repositories to GitHub. So there's a little arrow in the top right corner. If you click that, then you can click on New Repository. And from there, we're going to fill out the form that you see like this. So you'll create a repository, and the name should be Cookbook, matching the repository that you made locally on your computer. You can put in whatever description you want, public instead of private. And don't check the box that says initialize this repository with a README. We're going to just leave the repository totally empty. And when you've created the repository, you should be looking at a page that looks kind of like this. You want to click on the new repository link, and down near the bottom, there's a checkbox that says initialize the repository with a README. You do not want that clicked. Yeah, you want that to be unclicked. So then you should get a screen that looks kind of like this. So on this screen, what GitHub is telling you to do is it's telling you various different ways that you can put content into this repository that you've just created. Because a repository is just a thing that holds Git commits and branches and things like that. So by creating a repository, whether we do it on github.com or whether we do it locally by running git init, at the start, it's totally empty. So essentially, you've just run git init on github.com. That's what you've done. So in order to add new content, there are a couple of different ways you can do so, but the way that we're going to use is this one down here. We're going to push an existing repository from the command line. So you can take those two lines and run them. Git remote add origin, github.com, and so on, followed by git push-u origin master. You want to run both of those lines, one at a time. That's right. And once you've done that, you can refresh the page of your GitHub page, your GitHub repository, and you should see the commits that you've just created showing up on GitHub. So I'm going to try doing this myself as well. New repository. So I'm going to copy this. And then I'm going to copy this. If you already have SSH set up properly on your computer, you're welcome to do that. A lot of people find it easier to use the HTTPS link because that doesn't require getting SSH keys set up. Yes, you can. And I'll get it. Mm-hmm. All right, so I've just run this on my computer. Right over here. And you can see that we get all of this output after it asks for your username and password for GitHub. And it says, new branch master to master. And now, if I go back here to my cookbook and refresh the page, there are the files that I've created in my repository. And I can go to s'mores, and there's the recipe. I can go to salad. There's that recipe. And I can even click on the part where it says 3 commits up here above the files. And there are the commits that I've made. So the short hash is right here. Remember how you can just use the first 6 or 7 characters of a hash and it can refer to the full thing. If you want to see the full thing, you can click on the short hash, and it'll show you the whole thing on this page that describes the commit that you've made. It is exactly the same. So you can take some time to explore and play around with this repository that you've just uploaded, just to verify that it all looks good.
Behind the scenes, what we're really doing is taking that dot get and pushing it up to get
Exactly. And now that we've done that, I'm going to break down the steps of what we just did and explain every part of it so that you understand what we've done. Now, one thing I want to emphasize is the difference between a centralized version control system and a distributed version control system. If you remember, Git is a distributed version control system. That means there's no server, there's no clients. Every copy of the repository is a complete copy of the repository. A lot of people, a lot of teams use Git and GitHub like a centralized version system. A lot of teams say, all right, we're going to use the repository that's on github.com as our central repository, and every member of the team is going to have their own version of the repository that sort of pushes and pulls from that centralized repo, but we're going to treat the one on GitHub as the centralized repo. You can do that. That is a perfectly reasonable way of using Git, and that is a very common way of using Git. But I do want to make people aware that that is not the only way of using Git. And even when you are using Git in a sort of centralized style, it's still a decentralized, distributed version control system, and you can move your files anywhere. So what that means in this case, if I go back to my presentation, the 2 commands that GitHub wanted you to do are 2 commands that we haven't seen yet. There's git remote and there's git push. Now I'm going to talk about remotes first. Because Git is a distributed version control system, that means that every repository can talk to many other repositories on the internet, on other computers, or even other repositories that live on the same computer. You can do that if you want to. Not a lot of people do, but you can do that if you want to. So essentially what I have here is I have my repo in the center, and I have 4 different other repos that it knows how to talk to. And all of those repos are addressed by URLs. I have 2 of them on GitHub, 1 on GitLab, and 1 of them on a completely different website. When I run git remote, what that does is it tells Git, this is a remote repository that I want to be able to interact with on a more frequent basis. And I want to provide a nickname for this repository, a short name, because trying to type out these URLs is long. So when I run git remote, that changes it to look something like this. So now I might have 2 remotes that are on GitHub, one of which is called example and one of which is called origin. I might have a remote hosted on gitlab.com, which I call GitLab. And I have a remote hosted on a different website, and I would probably just call that remote your site or whatever. All that they are is nicknames.
And the nickname in the command that we ran was origin.
That's right. So if you go back here, you're saying git remote add origin is the nickname, and then you're providing the URL that corresponds to that nickname.
So origin isn't any sort of special variable.
It's not anything magical. It doesn't do anything just by being origin. However, it is a very common name that is used by a lot of people. It's sort of like a best practice. Typically, when you have 2 repositories that are very closely in sync with each other, Like when you have a repository on GitHub and you have a repository on your local computer, typically you'll use the term origin for that remote. And there are a couple of Git commands that if you don't specify an origin, if you don't specify a remote, it will assume that the remote you want to use is whatever remote is called origin. So in a way, it's sort of special, but it's just a name. It's just, you can name anything that you want. And you can set it up so that it uses a different remote by default as well. So it's sort of special, but not really.
You can add any number, git remote, add X, git remote, add Y.
That's right. So over here, we have 4 different Git remotes. But you can have as many remotes as you want. There's no limit to the number of remotes you can have. So that's the first command that it had us run. Git remote add name followed by URL. And you can also run git remote in your repository to list all the remotes that your repo currently knows about. And if you pass it a -v flag, V for verbose, it'll also show you the URL that that name corresponds to. And remotes are saved in the config file inside of the .git directory. So you were asking about HTTPS versus SSH in setting up the link between GitHub and your local repository. When you set up that link, you did so by running git remote add. If you ever want to change it, if you want to change from HTTPS to SSH or vice versa, you can just go into that config file and you can edit it. It's just a plain text file. You can use the git remote commands or the git config commands if you want to. But typically, when I'm mucking around that sort of thing, I'll just edit the file directly because it's pretty straightforward. And it gives me additional context about what it is that I'm actually changing. So just for kicks, git remote, origin, git remote -v. And there's 2 lines, one for fetch, one for push. I'll get to that in a minute. They should be the same. And if you do .git config, here is my git config. And here is that remote that I just added, remote origin with the URL and the fetch URL. You don't have to worry about this line too much. There's some fancy things you can do later on with making it easy to check out pull requests on GitHub, but let's not worry about that right now.
Is there any commenting in this? Like, could I add, some sort of comment to a line to?
This file is in the INI format, and I believe that the comment character for INI is semicolon. So Git doesn't put any comments by default because you're just using commands to populate and edit this file. But when you're editing it, sure, you can put in whatever comments you want.
Is this the Git configuration for this repository or for
This is the one for this repository because it's the one that lives in the .git file, the .git directory for this repository. You also have a .git config file in your home directory, and that is the global Git settings. The settings in that file will apply to all repositories you have on your computer. So that's why when you set your name and email address, you typically want to do that in your global Git config. But when you set up remotes, you typically want to do that in the local .git/config file, because that's going to be more specific to each individual repo that you have on your computer.
One more quick question. Go back to your slide where you had the 4 remote repositories. So only one of those would be called origin and have another name for the rest of them.
That's right. Each remote would have a different name so that you can differentiate them. However, you could, if you wanted, have 2 remotes that have 2 different names that both point to the same URL. You could do that.
It's another alias.
Yeah. Yeah, it's just an alias system. So now, anytime that you see the word origin when you're running a Git command, you know that that's just an alias for, here's the URL of another Git repo that's somewhere out there on the internet. That's all it is. So that's how remotes work. The second command that GitHub asks you to run is git push. And as the name suggests, this is a command that pushes commits from your repository to another repository. Now, when we run git push -u origin master, that sets origin as the default remote. -u is short for --upstream. So that indicates that we have an upstream repository, and we're linking together our local repository with this upstream repository. It's a little bit more complicated than that because that's dealing with branches, which, as I said, I don't want to get into yet. I'm trying to oversimplify things a little bit, just for the time being. So after you've run git push -u origin master once, that sets up that link between the origin remote and your local repository. That's the thing that says this should be the default remote. If I don't specify a remote, use origin. And so after you've run this once, you can run git push by itself, no further arguments. And Git knows which remote you want to push to. And the master thing is this branch that we were talking about earlier. Again, don't want to get too much into branches. It's its own sort of complicated thing. Let's deal with GitHub first.
So for right now, that's just a distributed copy is all it is. When you do push, it's just going to effectively overwrite or the remote.get with your local.get.
It's not an overwrite. It's basically an append operation.
Okay.
So you're not losing any data.
And that's why you're holding the reference to it, so you can compare hashes.
Exactly.
You said it knows then subsequently to use origin and master. Is that information stored in that config file?
Yes. And like all information in the config file, you can edit it and modify it. What was your question?
Is somebody else that have changed it to mean something? Is that someone, I guess, because there might be some other, you might use two different machines to push to the same master, and somebody else pushes to the master, and is there no warning, maybe you need to before you push or something?
You're talking about conflicts. And we are going to get to that. Believe me, we are going to get to that. But not yet. Let's keep things simple for the time being. All right. So in addition to making commits on your local computer, GitHub allows you to make commits on GitHub as well. One of the reasons why I like github.com is because it allows you to do almost every Git operation through the web browser. And that's what you're doing. You are, in fact, making Git operations, and you can share them using Git tools. So let's create some commits on github.com. You can edit a file, you can change the contents, and then you can make your commit. So I'm going to do that in the browser over here. If I can make this work. Oh, thank you. Is that? That's a little too big. Is that better? Cool. All right, let's say I want to modify my salad recipe. There's this handy little edit button right over here. Edit this file. And GitHub gives me a text editor interface. I'm going to call this, the best salad recipe. And this is where I put in the commit message. As you can see, there are two fields here. And this is just going in line with the standard that I was talking about for how commit messages should be structured. There's a short line at the top, followed by an empty line, followed by any sort of detailed message you want about the commit. Yes. So I'm just going to say this is the best, most. So you can type in whatever message you want. And And this section down here is again talking about branches, which again I'm going to put off until later. For now, commit directly to the master branch. Commit changes. And now that file has been modified as I wanted. And if you look up here, here's the information for the commit that I just made. You can even see that it assigned a commit hash. So you've actually created a file, ran git add, and ran git commit, all on GitHub through a web browser interface. You're doing the same operations you did, but you're doing them on GitHub instead of on your local computer. So now that you've made a modification to your repository on GitHub, the next question is, how do I get that modification onto my local computer? Not pull request yet, but a pull. Because we've already done a push, so the opposite is a pull. Pull requests are something different. So just like there's the git push command, there's also the git pull command, which gets commits from another repository and updates your files with those changes. You can specify a remote. If you don't, it's going to do whatever is set as the default, which we've set the default to be origin. Now, when I run git pull, that is actually doing two operations on Git. And those two operations are git fetch and git merge. Git fetch is the command that downloads additional information from the remote that you specify. Git fetch is what uses the internet in order to go out there and communicate with the remote. Git fetch just says, hey, what's new since we've last spoken? Git fetch does not modify the files on your computer at all in any way. All it does is get information, it doesn't act on it. Git merge is the part that acts on that information. So if fetch finds out that there are new commits, merge is what's going to update your local files to basically pull those commits in and say, yes, we want to take advantage of those new commits, and pull them into our local repository and update files based on the changes that they say. So we're going to learn more about merge right now. Not right now, after we learn more about fetch. So yeah, this is, as I said, just downloading information from the internet, doesn't make any changes. Merge combines the commits on a remote repository with the commits on your local repository. Now, if there are multiple changes that need to be merged together, let's say you have made commits locally and you've made commits on GitHub, and you want to combine all those changes together, merge is actually going to create a new commit, which is called a merge commit. And you can see in the diagram, it looks a little bit like this. You'll also see that every commit has a black pointer to its parent. So the arrows are pointing downward, but if you're looking at this diagram chronologically, the commits that are closer to the top are the ones that are the most recent. Every commit knows what its parent is. And we're going to get into those a little bit later as well. But the idea is when you run git merge, you're pulling together other information and updating your local repository based on that information. So another command that you should know is called git clone. And this is a command that does something similar to git init, but it's something that you're going to be doing probably more frequently. Git clone makes a local copy of a repository that's available at the given URL. So if there is a repository on GitHub that you want to make a local copy of on your computer, you could, if you wanted to, run git init to make a local repo, run git remote to set up the remote between your local repo, and then run git pull to download the information. But it's a lot faster to just say git clone. That does all of those things. It makes a local repository, it downloads the information from the URL that you specify, and it sets up a remote named origin. And this copy of the repo that you make, that is yours. You can do whatever you want with it. In Git, that's called a fork. If you talk to someone who has done version control for many years with centralized version control systems, and you talk to them about forking a project, typically the reaction is along the lines of shudders. Like, why would you do that? Because in the past, with a centralized repository, forking is a really expensive and difficult operation and usually results in fractured communities and can be even the death of a project. With Git, it happens every day, multiple times a day. This is just the normal way of doing things in Git. It's a very different mindset. And the reason it's such a normal thing is because it's easy to fork and it's easy to merge forks back together. So every person in the community, every person in your company or what have you, has their own fork of the repository. And all of these forks are under different individuals' control. They're under the control of whoever owns the fork, but they can all work together in harmony very easily. So these are the commands that we've learned now for collaboration. These are the commands that allow you to exchange information with other repositories on the internet. You can use them with GitHub. You can use them on your local server. You can use them with other repositories on your computer. They're for collaboration however you choose to use them. Does anybody have any questions about these commands? There is a reason, but we haven't gotten to the context for that yet. I just wanted to clarify that pull is sort of an umbrella over these two different things. For the time being, you don't have to worry too much about it, but we will get to the difference later on. I apologize that I've been doing a lot of, we'll get to it later, we'll get to it later, we'll get to it later. It's because there's a lot of pieces of information that I'll link together. Anyone else? All right, and further review. All the commands that we know so far. You see how these all work together. This is where we're getting to the point where you can see how Git is seen as a very complex and complicated system, because in order to use it effectively, there are so many different pieces that you have to learn. And all of these pieces work together. But every individual piece is pretty straightforward. So if you're confused about how to do something, you can try to break it down into its component pieces and learn how those pieces work. So let's do something fun. I have a repository that I've prepared ahead of time, which is at github.com/singingwolfboy/tutorial-cookbook. So the repository that just created 10 minutes ago was called Cookbook. This one is called tutorial-cookbook. Try making a new file in the repo and push it up to GitHub. And as you can see, it's not going to work. But you should give it a try anyway so that you can see the error message that you get. So you can run git clone github.com/singingwolfboy/tutorial-cookbook. And then make a change, make a commit, and then try doing git push to send it back.
Is there an optional .git on the end of all these URLs? I noticed that some have a .git at the end and some don't.
Oh, I think that should be on the slide and was missing from the slide. Yeah. So the URL that GitHub uses for accessing the HTML version of the page does not have .git. But if you go to this clone or download section, this is the URL that you should use. And at the end, it does have .git after it. So thank you for catching that. I think that you want to use .git for that.
So you want us to create the new file in GitHub or on our local machine?
On your local machine. And then try pushing it back.
In our repo or in a new one?
So when you run git clone followed by this URL right here, that's going to make a new repository on your computer.
Oh, okay.
I'm sorry if I wasn't clear.
Even here in that original directory you're operating in, it's going to make another one.
Yes, it's probably easier and cleaner if you go to a different directory on your computer and make the new repository there. I believe it'll still work if you try to make a repository inside of another repository, but things might go kind of wonky. I'm not exactly sure. It's going to create another .git folder inside of the repo that you're cloning.
Get the URL in big letters so I can type it in?
Yes, it is github.com/singingwolfboy, that's me, /tutorial-cookbook. So who's the first person to find the error message? Push it back up to my repo. Exactly. So I have created this repository. It is my repository. I own it. None of the rest of you own it. So any of you jokers trying to make changes to my repository without going through me first are going to get a 403 error saying you're not allowed. So it's a permissions thing. That's what I mean by every repository is under the control of whoever makes that repository. It's my repo. It's not your repo. That being said, you can make a pull request. And when you make a pull request, you're actually going to fork my repo, and that fork of the repo is going to be your repo, and you are going to have permissions on that. So with a pull request, conceptually what you're doing is you're forking the repo so that you have control over it, and therefore you can push commits to it. Then you're going to make any sort of commits you want in your fork and change it however you want because it's yours.
So when you say you're forking the repo by cloning that repo, you fork it, is that correct?
Yes, essentially. A clone is another full 100% copy of the repository, and because it's your clone, you can do whatever you want with it. So the operation is cloning, but what you have afterwards is a fork. And then once you have your fork of the repository that is under your control, you can change it however you want. You can delete all the files, and you can, add pretty pictures of unicorns if you want.
I'm a little confused because you say get clone and then you have the URL and then you try and make an edit on the clone and it's not you saying that once we clone it we fork it. So what's the problem?
You can make changes on your clone, but if you want to send those changes back to the version on GitHub that you started from, you're not able to do that.
Oh, okay, so it's not actually so the clone is only local, it's not
That's right.
right. So you're supposed to fork and then clone your fork.
Yes, exactly. So the way...
You're holding a reference, so if you take me off the
Mhm.
you're making a local copy, and you're still holding a reference to the master copy for the purposes of your push.
Exactly. So when you run git clone, as I said, that is just sort of like an umbrella operation. It does git init, it does git remote add origin, it does git pull, and downloads all the copies, all the commits from that other repo. So you have your own repository, but because you've done git remote add, your copy, your repository, has a reference over to where it came from.
And behind the scenes, you've got all the files on your file system, and then you've got a copy of the current state of their .git directory locally as well. So
Exactly.
that's how it knows to sync to.
Exactly. So you can make local clones on your local computers, but you cannot send your changes to my repository where it came from because you don't have permission for that. But with GitHub, you can make a pull request. So over here, I have my own clone of the Django repository. Django is an open source project. The primary repo is hosted on github.com. And you can see over here, forked from Django/Django. That is the upstream version. So I have my own copy of Django. It's great. I can add ponies and unicorns. Once I have a change, you can say I have one commit ahead of Django master. There's a button that says new pull request. And if I click that button, GitHub is going to show me a view where I can compare my changes with the changes that Django owns, so I can see the changes I've made. And then there's a button where I can actually create the pull request to send a message to the people who run Django saying, hey, I have this great change that I think you should all pull in. It adds more rainbows and unicorns to Django. So give it a try. You can't push code to my repository, but you can send pull requests. So the way that you'll do this is you're going to fork my repository. And the way to do a fork, let me show you how to do this. In fact, I will just go to GitHub Django. So this is not my repository, but up here at the top, there's the three buttons, watch, star, and fork. So lots of people have forked this repository. And if I want to make my own fork, I can hit the fork button. And it's going to ask me which of the various different communities I'm a part of that I should make the fork to. And I'll say, I want it to go here, to my account.
Just to clarify, you're doing the same thing, like your version of GitHub as we just did locally with that fork. It's like a local clone, except for it lives in GitHub.
Exactly. One of the things I really like about github.com is you can basically do Git operations through the browser.
Yeah.
So I've just made this Django fork.
Is there a command line to do the remote?
So all of the Git operations on the command line work only on your own computer. So that's why there's this whole process of doing a clone and making a fork and sending a pull request, because you can't use vanilla Git to do Git operations on GitHub. GitHub is a website, and you can, they expose an API, but the Git tools by themselves can't use it. All that being said, GitHub does expose an API, and you can do this from the command line using special tools that work with Git, but Git by itself cannot do that. Does that make sense? Okay.
So you're saying a pull request is that a GitHub-specific maneuver?
It is, yes. So the concept of pull requests was popularized by github.com. They didn't originally come up with the idea. The people who developed Git came up with the idea. But github.com was the company that popularized it and made it really easy to use. And as a result, a lot of people think that github.com invented pull requests, which is almost true, because before GitHub, nobody knew about them. Now that they are so well known, other websites have analogs to pull requests as well. So for example, there's another website called GitLab, and they have merge requests, which, because they believe what you're actually doing is you're requesting someone to merge your code into their project, so it makes more sense to call it a merge request. But it's the same concept.
The old school way of doing this would be email with your project collaborator.
Exactly. The old school way is make a patch, send by email, and pray. So here's my fork of Django. I can do whatever I want with this fork. I can add ponies and unicorns, I can delete all the code, and it's great. And it doesn't affect the main Django project at all. So similarly, you should all fork my tutorial cookbook repository. And if I go over here and I wait for it to load, please load, there it is. Now I can see that a bunch of you have. A bunch of people have already made forks. And in fact, somebody has sent a pull request. So I can go over to my pull request view and see, all right, this person over here has added a recipe to my cookbook. And I can see the description that this person added for this pull request, and I can go over here to Files Changed. And here's a recipe for a Manhattan. Awesome. See, this is a collaborative cookbook that we're all building together. So I'm going to say, and we wait for GitHub to load. There we go. Now I've added a comment, and I'm going to merge it. So this is where it's asking me to add a commit message to the merge. The default commit message is fine, so I'll just confirm that.
And then in your repo's log, this shows up as that commit from you accepting the pull request.
So now, if I go back to my repository, then we should have a recipe for a Manhattan. Once this loads. Yeah. Nothing I can do about that. But I can go over here, and I can do git pull, and that will try to pull commits from GitHub, and you can see that now more commits have been added. Oh, sorry, this is the wrong repo. This is the cookbook repo, not the tutorial cookbook repo. Yeah, so here's the recipe I had before. Now if I do git pull, and wait, and wait, and wait, theoretically, eventually, it'll pull down the commits that were merged on github.com, and I'll be able to see those changes on my local computer as well. I don't know why this is taking so long. Yeah, I just tried that up here. All right, I'm going to proceed as though this has worked. And you are all going to believe me because you are a wonderful audience. Yeah, exactly. So because with Git, you actually attach your username, your name and email to each individual commit, all of that authorship information is actually preserved. Even when you make pull requests and merge commits from other people, you can see who authored what. So even here in my repository for Tutorial Cookbook, I can see that this person made this commit to add this. It's not me, it's someone else. Exactly. And incidentally, fun trick you can do. Because Git makes the authorship information based on whatever you specify in the .git config file, you can modify your name and email address to be Guido van Rossum, and you can make commits and look like they come from Guido. There are ways that you can verify that the commit you make comes from the person that you actually say you are, but those ways involve PGP keys and doing cryptographic verifications, and it's all way over my head. But yeah, if you want to have some fun, you can impersonate whoever you want, and Git will allow you to do it. Okay. So you can also merge pull requests manually using Git. You don't have to use the merge button on a pull request. You can add a fork of the person who made the pull request. You can download the information from that person's fork using fetch. And then you can merge their branch into yours, their master into yours. So that's why I'm doing git merge remote/master, and then push. And GitHub will automatically update the pull request to indicate, oh, hey, this has been merged. Congrats. It's done. And I would show you right now, except that the conference Wi-Fi is crapping out, so I'm not going to show you. So again, you are going to believe me because you are a wonderful audience. In my fork of Tutorial Cookbook, yes, that is correct. In your fork of Tutorial Cookbook, you are the only one who can merge pull requests coming into yours. So because Git is a distributed network, and anybody, any repository can talk with any other repository, people can make pull requests not just into my fork of the code, but also into your fork of the code, or anyone's fork of the code. So that's why it's not a centralized model. It's a distributed model. Anybody can talk to anyone, and anyone can treat any repo as the central server. There isn't actually a central server. It's just whatever you sort of treat it as. You can.
Let's say I make a pull request to your repository
Mm-hmm.
for my local, not my GitHub.
Yes.
Or fork that I make. So off my local clone, and then I shut the laptop down and go away for a couple weeks. It obviously doesn't just send you a pull request, it sends you the information inside whatever it goes in, right?
So a pull request is a GitHub-specific thing, as I said. So if you shut down your laptop and put it away, and someone tries to send a pull request to your clone, that's not really going to work. Now, someone could mail you a patch and ask you to apply it.
What's the Git version of
There is actually a Git command called git space request-pull, which is backwards. But there is a way that you can do that. However, because pull requests on GitHub and on GitLab or wherever are so nice in terms of being able to view them in a browser and comment on them and interact with them, most of the time, people use GitHub pull requests rather than trying to run git request-pull and mailing patches around and doing all of those other things. But you can if you want to, but don't. So as I was saying, GitHub is not the only game in town. GitHub is a Git host, but there are other Git hosts. GitLab and Bitbucket are two other really good options. And one of the nice things about those options is you can get private repositories for free on both GitLab and Bitbucket. With GitHub, you can upload as many repositories as you want to, but if you want to make any of them private, you have to pay money. So if you're working on a little side project and you want to keep it to yourself because you want to make a little software startup and you don't want to share the code with other people, you can't do that with GitHub unless you pay GitHub, which is fine. You know, it's their business model. It's how they make money, and I respect that. But you can do that for free on gitlab.com and on bitbucket.com. You can even take a repository that's hosted on github.com, clone it to your computer, and push a copy to gitlab.com and make it private. Because they're all just clones in the network. It's just a network. There's no centralized server per se. So if you want to do that, you can. GitLab is a great website, and unlike github.com, the source code behind GitLab is itself open source. So you can run your own GitLab server within your company, and none of the source code ever has to go outside of the company, which is pretty cool. But unfortunately, the Wi-Fi is being a bit difficult. Yeah. Yeah. I don't know what's going on here. But again, you are going to trust me, and we are going to move on. So yes, another time when there's better, more reliable Wi-Fi, you should check out other options, and you should try pushing and pulling between them. A lot of people in the world believe Git and GitHub are synonymous, and they are not. And if that is all that you learn from this tutorial, that they are two different things, I will be happy. Because it really bothers me when people conflate the two. Uh-huh.
So when I forked your cookbook master,
Mm-hmm.
in order for me to be able to now have have that repository, then I need to clone my forked repository.
So yes and no. Remember that the repository that is on GitHub and the repository that is on your local computer are two different repositories. They are clones of each other, but they are different. What that means is the normal workflow that most people do is if they want to make a pull request to an open source project, first, let's say the open source project is here. First, they will clone the project to their GitHub repository. Then they will clone from their GitHub repository to their local computer. And then, exactly. Yes. Yes. However, there are a couple of other options. You could clone from the remote to your GitHub, edit on GitHub, send the pull request back. You also could clone from the open source project on GitHub to your account, and then clone from the open source project onto your computer and set up a link, a remote, between these two. And that way you can share commits with your local copy, which then from here you can send a pull request back. So again, you don't need to do the whole 3-hop thing back and forth. You can, a lot of people do, because it sort of makes sense. But if you want to clone directly from the open source project and then just add a remote, you can do that. I get a lot of questions from people saying, hey, I cloned from this thing and then I forked it on GitHub, so now I need to delete my local repo and reclone it, right? And the answer to that is, well, you could do that, but that seems like a waste when you could just set up a remote and share the commits directly without having to delete everything and re-download everything. Make sense? All right, any other questions? Mm-hmm. Yes. Hmm.
And I'm sure because it's just what happened to me, because I just say, okay, remote is fork now, my fork on my GitHub account, and now I just say pull, I didn't say anything, I just said pull.
Interesting. I'm not sure what's going on there. Maybe Gil can help you out, or I can help you out afterwards.
But now the question is, if I push again, does it go to the rich directly, or does it go to mine?
So that depends on how you set it up in the config file or the -- upstream. But again, that seems like a specific issue to you, so I'm going to move on with the tutorial. All right, so it's about 11 o'clock, so we are basically on time because we've done the first 2/3 of the tutorial. The last third is on branching. This is that thing that I kept on pushing off and pushing off and pushing off. Now we've finally gotten to it. So this allows you to move commits around within a repository, because we've already learned how to move commits between two different repositories using push and pull. But branching is really interesting in Git. So here's the problem. Let's say you want to propose two separate pull requests that are unrelated to each other. One is adding a new recipe, one is modifying an existing recipe. If you try to make two pull requests based on what we know so far, you can't do it. Because the way we've been doing things, once you fork a repo and you send a pull request, that's all. You can't do multiple different requests between two repos. Of course, Git is more flexible than that. And the way that it's more flexible is with this branch model.
Questions related to what you just said.
Sure.
When you do a pull request, what's the timing dependency? Like, what if you change files on your disk after you've made the request?
So the way that that works is GitHub treats pull requests as having two defined repositories and two defined branches inside of those repositories. So far, the only branch we've been using is the master branch. So what that means is if you push commits to your GitHub repository on the master branch when you already have a pull request, those commits will get automatically added to your existing pull request, which often is what you want, but sometimes isn't. Sure. So in order to understand how branches work, we need to rewind a bit and update our knowledge and our understanding of how commits in Git are actually structured. Because this goes into some of the sort of fundamental pieces of how a Git repository is put together. So this is a diagram of a commit. It's a metaphorical diagram. A commit has two parts, the content and the metadata. And they are closely entwined together, which is why I have the Zen symbol. The content is the actual text that you put into the files. The metadata is things like the commit message, the author, the date that the commit was made, and so on. One of the whole reasons why we have version control systems is to maintain not just content, but also to maintain metadata. To be able to say, I know that at this point in time, this file looked like this. That's all metadata. That's to be able to go back in time and say, these changes occurred over time like this. So this is one commit. This is two commits together. Most commits in your repository have a parent pointer. Each commit points to its parent. And that means that you can go backwards in time simply by following these chains of pointers. That's why when we used git checkout to check out an older commit and then ran git log, you were able to see the commits that were even older than that, but you couldn't see the commits that were more recent because these pointers only go in one direction. They only go from child to parent, never the other way around. So once you're on a Exactly. It's a singly linked list. So once you get to a particular commit, you can only ever see its parents. Now, this is sometimes annoying. It means that you can't get a list of all of the children commits of any particular commit, but it allows you to do some really interesting things. So we've talked about this idea of master. Master is actually the default name of a branch in your repository. And a branch is simply a linked list of commits that starts with a particular label and goes back in time all the way until the initial commit of the repository. Incidentally, the initial commit of the repository is the only commit that does not have a parent pointer because it has no parent. So what we're looking at here is a repository of 3 commits. And you can see that the parent pointers are pointing downward. And I have a little helpful guide over here showing that the top of the graph is the more recent commits. So in Git, a branch is implemented as a label that points to a commit. And these labels are flexible, they are movable, and in fact, they move pretty frequently. So if I were to add another commit to this branch, that label would automatically move to point to that new commit. So a branch is just a labeled commit and all of its parents going back one at a time in a list. And all of its parents. So if someone were to talk about the master branch of a repository, what that means is find the master label, find the commit that that label points to, and that commit and all of its parents is the master branch.
Whereas if you had another branch, it would go over and down.
Mm-hmm.
You wouldn't necessarily have the master because it's a lower level.
Exactly. So this also means that any time we create a new commit, if we're attached to the master branch, that label will automatically update and point to that new commit. So this helps us to understand that detached head warning that we saw earlier on. Head is a reference to whatever commit you're currently sitting on in Git. So when Git warns you that you have a detached head, that means that you are not attached to one of these branch labels. And when you make a new commit, that commit will exist, but the branch label will not update to point to it. As a result, if you leave that commit behind by using git checkout to go someplace else, there will be nothing that points back to that commit, and it will be very difficult to get back to it. Whereas when we have this handy master pointer, we can always say, just go back to master. And it says, oh, I know where that is. That's this commit right here. And every time you add a new commit, it updates this. So you can always say, just get me the latest commit. And it always knows exactly where that is because of this pointer. Now you can also have multiple branches. So let's say you have a repository that looks like this. At some point in time, this was the latest commit in the repository. And somebody made a pull request starting from this point in time. They forked the repo, they made a new branch, and called it fixed typos. And they corrected the spelling of the word ingredients, which is something that apparently I can't spell. And then they send that back, and here is that child commit. But the master branch can continue going onwards. This is why it's really handy, actually, to not be able to view all of the children of any specific commit, because it means that you can have many children pointing to an individual commit, and you don't have to keep track of them all. You can have as many children as you want, and in fact, you can have a distributed system where anybody can make children and send pull requests back, and it all works. You can also add more commits to that branch, and it's going to update whatever pointer you are currently attached to. So if you're on the fixed typos branch and you make a new commit, it's going to update the fixed typos label, the fixed typos pointer. It's not going to touch the master pointer. Is all of this making sense so far?
You had said that you don't want to know the children of that where the branch happened. But surely at some point you actually do want to know if there's siblings. Because if there are, you're probably going to have to merge at some point before you.
Not necessarily, because there's no reason why you can't make commits that are designed to be like throwaway commits. I'm just going to try this out, see if it works out, and if not, I'll get rid of it. Or just stop using it anymore. The only commits that you care about are the commits that are in the branch that you treat as the primary branch, which by convention is master, but you can use whatever primary branch you want. And you also care about commits where people are making a pull request into the branch that you believe is primary. So if somebody has added 2 commits to this fixed typos branch and they believe that those commits are worthy of being included in the primary branch of your project, they might make a pull request back. And from there, you get a merge commit that pulls those both in. Merge commits can have more than one parent pointer. So this pointer, merge commit has 2 parents. It has this commit, which was the old master, and it has this commit, which is the fixed typos branch. Now, because I was on the master branch when I made that pull request, I've also updated the master pointer to point to this merge commit. So now, if you were to find all of the commits in the master branch, you would find all of these, but you would also find these 2 commits in there as well, because they've been merged together. And because of the way that Git does this, you can still clearly see that these 2 fixed typo commits were made at a separate point in time than the other commits that went into master. So it allows you to preserve the structure of your history. Does that make sense? The reason I've designed the merge commit differently is because Git actually treats merge commits as special. And there are certain operations that are difficult or impossible to do with them because they have multiple parents. And that's not really within the scope of this tutorial because I only have another 40 minutes with you. But you can learn more about that by going to Git's website and learning more by...
You said a merge can have multiple parents.
That's right.
You showed 1, then 2.
Mm-hmm.
I'm assuming you mean 3, 4, 5. So a merge can point to...
That's right. A merge commit can have as many parents as it wants. Most of the time it's 2. just because that's simpler.
In this case, does the merge commit identify master as what everything is being merged into? There's one branch that's identified as the one that then will have all the history going forward, or does fixed typos also have all that history in it now after you do it?
So even after you do this merge commit, if you were to run checkout fixed typos, you would end up here because this label hasn't changed. And remember that when you're running git log, all you can see is the pointers starting from where you are. So from here, you would see this and this and this. You would not see that. So fixed typos hasn't changed in the slightest. You have added a new commit to this repository and you have changed the master pointer to point to it. But this pointer hasn't changed. And so you can still check out this branch and it is exactly the same as it was before.
Okay, so the merge commit is in the master log, but it is not in the fixed typos log.
Correct. Does all of that make sense?
So in that, before you did the merge, the master was pointed one down,
Mm-hmm.
down. If I do a checkout master, I don't see the fixed typo.
That's right. So at this point, if you run git checkout master, you would see these 4 commits, and that's all. So now that we have some idea of what a branch actually is, it's just a label that points to commits. Now we can start using the commands that Git provides to use that. So git branch is the basic command. If you run it without any arguments, it will show all the branches that currently exist in the repo and which one you're currently attached to, if any. You can also run git branch followed by the name of a branch in order to create a new branch. And that new branch will point to whatever commit you're currently sitting on. And if you do git branch -d, that will delete a branch, which again, only deletes the pointer. It does not delete the commit. Because these operations are on pointers, not on commits.
So the git branch displays all the branches regardless of what commit you're currently seeing.
That's right. Git branch is the thing that allows you to see what your options are for jumping around through history.
So,
Hmm? Yeah.
so if you just want to clean up, you can delete the branch after you've done a commit.
Well, you can if you want to, but generally the only times that you would want to actually delete a branch is when the branch is no longer relevant. Like at this point in time, the fixed typos branch is no longer really relevant because all of those commits have been merged into master. So this might be a time where it would be nice to clean up fixed typos.
Is the merge, does that include all of the interim commits that created the branch?
Yep.
Those will show up in master's lineage?
That's right. And there are commands that you can do to show not just a linear list of commits in master, but also to show this whole layout of the way that the commits branched and merged back together. There's actually a git log -- graph option that you can pass to git log, and that will show you this graph of all the commits. If you've deleted this pointer, if you imagine the pointer is gone, the commits are still there. And if you start from master and you ask it to show you the graph, this merge commit still knows that it has 2 different parents. Exactly. Specifically, the merge commit's metadata knows that it has 2 different parents, and it knows how to display that in a graph form.
You lost me on that error pointing down the fixed typos from master.
Mm-hmm.
I'm still unclear as to what that is. So I get it, at some point you took a copy or you made some changes and you deposited those changes and merged them back into the second
Mm-hmm.
circle. But why is that line pointing from master down to fixed typos?
Because the commit at the very top of this screen right now is called a merge commit. And the purpose of a merge commit is to merge together 2 or more branches of the code base into one. So the merge commit knows that those 2 commits that it's pointing to are designed to merge together. So any work that has happened in this branch will be marked as merged into master and will be reflected in all future commits that are made after that merge commit.
I'm sorry, I read the arrows the wrong way. I read
Yes.
you were putting, okay, I got you. I thought you made your branch merge into the second from the bottom, but you're actually merging right at this point.
Exactly. Exactly. So remember, each of these black arrows are arrows from a commit pointing to its parent.
Predecessor.
Exactly. And you can see over here, oops, most recent commits are at the top.
Okay, so that the second one was where I actually took the branch off. Now I'm rejoining the branch to the trunk, if you will.
Yeah, so the branch split here, work continued, and then at some point, people decided, actually, we want to take this work and merge it back in.
Now, what happens in the future? Is there any sort of link, or like when you, let's say, fixes typos, gets a new update? Is there any? There's always that same commit that emerged.
Yep, the way that we've done it here, that will always be the case, and you'll always be able to see that fixed typos used to be a branch and was then merged in.
Okay, so there's no magical sort of updating. It's always there has to be some decision made. Now, so if this is two different people, who has authority over committing to the master? Is it the only one person?
It's not two different people per se. It's whoever has control of the repository is who has control of how these commits work. Remember that other people can send pull requests. Other people can say, I have forked the repository at this point. In my repo, I have added some more commits. I would like you to pull them in with a merge commit. But you don't have to. It's the person who accepts or rejects the pull request that decides which commits get in.
And that could be a number of people.
Yes. And actually, I think I'm going to explain this a little bit more in a few more slides. So I'm going to keep on going for now because we're running low on time. So git branch is the command that you use to create, modify, and delete branches. Well, actually create and delete branches, not so much modify them. And here's a shortcut. You can also do git checkout -b and provide a branch name to create a new branch and immediately switch over to it. Create a branch and activate it. Most of the time, you're going to end up using this shortcut. That's what I use all the time. This is actually the thing that when you get that detached head warning, it recommends if you want to save your commits, you can make a new branch right now by doing git checkout -b and passing the name. So you'll see this sometimes. Every branch also has its own upstream setting. Different branches can default to different remotes. So when I said earlier that you set up a default for your repository, that was a little bit of an oversimplification. Actually, each branch has its own upstream by default. So what we did earlier when we did the GitHub thing, we did git push -u origin master. That said, for the master branch, set origin to be the default upstream. -u for upstream, origin, master. Normally, the branch in the remote repo has the same name as the branch in the local repo, but that doesn't have to be the case. It's really just for consistency. So if you want to have a branch with a really long name on github.com to make it clear to people who are viewing your repo what this means, and on your local computer you want it to be like a short 3-letter abbreviation, you can do that. There's no reason why you can't. It's just most people set it up the same. So, for example, here's that same repo we were looking at before. You might have your local repo and your remote repo that are identical to each other, but then the upstreams are set up like this. So the fixed typos branch knows that its upstream is also named fixed typos on the remote repo, and the local repo knows that its upstream is also named master. The master branch on the local repo knows its upstream is also named master. Does this make sense to people? So if we had more time, I would suggest you all add more chocolate to a recipe in my repository and modify it, push it up, make a pull request. And we would see that you could do that with multiple different branches. So you could check out a new branch called add chocolate, make a commit that adds more chocolate to it, and we would have a cookbook full of chocolatey recipes, and it would be wonderful. But between running low on time and the Wi-Fi issues, I think I'm going to skip that for now. Does this idea make sense to people? Okay. Another command I want to go into is a command called cherry pick. Cherry pick allows you to create a new commit based on an existing commit. So the thing that I use it for the most often is I've just created a commit and I realize, oops, I was actually on the master branch when I made this commit, and I intended to make a new branch for that commit. I intended to make what's called a feature branch, and then make a pull request from that feature branch into master, so that other people on my team could review the change before it goes into master, rather than just making changes on the master branch and pushing them immediately. It's part of the code review process. So with cherry pick, I can pass it a reference to a commit, and it will pull the commit over effectively. It won't actually move it, it'll create a new commit. So let's say I'm here, and in this case, the example I've put together is I have this fixed typos branch, and I have commit C. And I want to get C onto master, but I don't actually care about this commit. So I don't want to do a merge, because if I did a merge, I would get both of these commits. I really just want this one commit C. So what I can do is I'm sitting on master, and I can run git cherry pick, followed by a reference to C, which might be the commit hash. And it makes a new commit on master. And that commit C prime has the same changes and the same authorship information as commit C. You're not actually moving the commit. You're making a new commit that is as close a copy as possible to it. In effect, you're cloning it. Does that make sense to people?
So you don't have the changes that were in the parent to C.
That's right.
Do you have the changes that are different between the fixed typos branch and the master branch?
Each commit, as I was saying, has two parts. There's content and there's metadata. This commit has a certain amount of content, which is a diff, add additions and removals. This commit C prime has exactly the same additions and removals as C. But this commit is different. So by running git cherry pick, we can get this commit over without grabbing this commit.
So you're not taking the lineage, you're just taking the actual content.
Just the content from this one.
Doesn't that still have to merge into the master?
It does, and it is possible to get conflicts. It is possible to get conflicts doing this, but we're not worrying about that quite yet.
Is there any reason you ever use git cherry pick within the same branch? Is it always moving a commit from one branch back to another branch?
You could have a series of commits where you have a commit that adds a feature, and then a commit that reverts it, and then you might want to add the feature back, and you could cherry pick the original version if you wanted to. There's also a command called git revert, which does like the inverse of a cherry pick. So it takes the content, and every line that was added, it removes, and every line that was removed, it adds. Same basic thing. Cherry pick and revert are almost identical to each other, just inverted. You can also use the git reset command to move around the branch pointer to point to whatever commit you want. So this was a command that we saw earlier on when we were modifying the contents to undo, to back out some of the changes we had done. Reset allows you to modify how branch pointers work and also to modify the files on disk as a result. So I can use git reset to change around how some of these arrows work. In this case, I have copied this commit over to here, but I haven't actually removed this commit. The commit's still there. So I probably want to use reset to change this pointer to point to this commit instead of pointing to this commit. So we can do that with git reset. And we can use relative references as well. So you can modify any reference in Git by adding tildes after it to point to its parents. So Yes. So by doing this, this command says reset the branch pointer that I'm currently sitting at to point to the commit that is the parent of the current commit. In effect, reset this pointer to find the parent and make this point here. You can use multiple tildes to back up multiple parents, or you can define a number. So tilde, 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 tilde is exactly the same thing as tilde 5. You can also provide these references after a branch name. So you can say master tilde, or fixed typos tilde, or any reference you want. Huh? Oh, reset, as I said, can modify both branch pointers and files on disk. By default, it will just do the branch pointer. If you pass --hard, that says also update the files on disk to make them exactly as they were at this commit that I'm pointing to. So this is what I was showing you. After doing that reset, we've made this branch pointer point back here. And now, this commit C is very difficult to get to. It's not impossible. If you know the commit hash, you can always check out the commit hash. But now that commit is basically sort of floating in the ether, and nothing is pointing to it. And Git's garbage collector, because yes, Git has a built-in garbage collector, will eventually come around and clean up any commits that don't have any references pointing to them. Yes. So this is what I was talking about earlier. This is what the detached head warning means. Head is the current commit. Detached is not attached to a branch. New commits will also not be attached to a branch. Use git checkout-b to create a new branch to preserve those commits so you can find them again. Conflicts. Let's see if I can cover this in 20 minutes. If you try to cherry pick a change that already happened on your branch or something that doesn't exist, then you're going to get a conflict, which looks something like this. And Git knows that this file is in conflict, and it doesn't know how to resolve that conflict. So the file will actually be altered to show you, the developer, where the conflict is, and it's going to actually insert these lines into your file. The
Conflict in this case means that there's difference in, there's changes in the two commits
Exactly.
required to resolve that.
Let's say you have a recipe and one person said, I'm going to up the amount of chocolate from half a cup to 1 cup. And someone else says, I'm going to up the amount of chocolate from half a cup to 2 cups. And you want to get both of those commits in there. How do you resolve that? Is the answer 1 cup? Is the answer 2 cups? Is the answer 3 cups? Maybe that's the correct answer, but Git doesn't know how to do that. So it's going to show a conflict and ask the developer to resolve it for you. And it's also only going to show the lines that are actually in conflict. So in that example that I just provided, all the directions of the recipe are going to be not in conflict because they weren't changed. It's only in the ingredients section where that conflict is going to occur. And it's going to show you that file. It's going to show you the parts of the file so that you can modify them. So in order to resolve the conflict, you want to actually open that file in a text editor and change it to look the way that it should look after all these commits have been resolved together. So you would actually delete this line, this line, this line, and set the number of cups of chocolate to be whatever the correct value should be. And after you do that, you're going to use, not what I expect. After you do that, you're going to use git add to indicate that the conflict is resolved. And then you can keep on going with the normal commit process, just doing git commit like you would after a commit after doing git add. Does this make sense to people? If you've done version control before and you've had to resolve conflicts with something like Subversion, this is pretty familiar. If you haven't done version control before, then it's new and it's a little bit scary, but you can talk to someone else who has, and it's a very familiar problem in version control.
But it's not going to open up the text editor, two file versions.
No, it's going to let you do that, and then After you've run git add, after you've resolved the commit, then you're going to have to run git commit, and then it will pop open the text editor, and that helpful commit that you saw earlier, the commit message that has all the detailed comments and everything like that, that will actually tell you you are doing a resolution to a conflict, and these are the files that were in conflict, so that you know, so that when you write the commit message, you know the context of what's going on. Make sense? Cool. So, rebase. Rebase is something that a lot of people hear about with Git and are very scared by, because rebase is the command for changing history. And people hear that and they get all freaked out. Like, why would I want a version control system to change my history? Just like most of the other tools we've discussed so far, rebase by itself is not actually as complicated as you might think. So essentially, all it does is a series of cherry picks. You're going to give it a reference to move a branch to, and it's going to cherry pick that branch one commit at a time. Here's an example. Here's our fixed typos branch that we had before, and master is pointing at commit D. If I run git rebase onto master, starting from the fixed typos branch, then it's going to cherry pick commit E and commit F onto a new branch with commits E prime and F prime, and it's going to move the branch pointer to point at that new branch as well. Essentially, you could think of it as finding the base between these two branches, lifting up these commits, putting it down on top. You have rebased the branch.
Does that automatically just work between the master, or you get yourself onto the commit that you want to start with, and then the harder one is the one you reference?
Yeah, the second one. You get onto the branch you want to start with, and the target is the reference.
Can I just make a comment about the graph? I think it would be less confusing if arrows pointing down, pointing the other way. If you're thinking in time, and as the association goes that way,
I can understand that it's confusing. This is more accurate because each commit has a pointer to its parent, not a pointer to its children. So oldest commits at the bottom, most recent commits at the top. Each commit is pointing back down from itself to its parent, which is why I've done this diagram. I agree it's a lot of arrows, it's a lot of things to keep in mind, but I wanted to keep this accurate as much as possible. So that's what's going on here. You just find the base, and this one, you make a new commit that has a new parent pointer. This is its parent instead of this being its parent. That's what the arrows mean. So the reason why by doing this you are changing history is because think about the perspective of somebody else trying to use this fixed typos branch. Before you do the rebase, the history is FEBA. After you do the rebase, the history is F prime, E prime, D, C, B, A. Not only has the content changed, because these two commits weren't there before, but all the commit hashes have changed as well. So you're essentially sticking these commits in the middle of history, where they weren't before. And the important thing to realize is your old version is still here. As long as the git garbage collector hasn't run yet, and it doesn't run very often, you can always go back to the old version of this branch. But by doing this, you are inserting the latest changes in master underneath the changes in your branch, which can be handy when you have multiple small teams working on features in a code base, and you want to make sure that your code is all up to date with the latest features that have merged into master. So this is a good way of doing that. It means you don't have to deal with tons and tons of merge commits constantly pulling in from master. You're just lifting up your work and dropping it on top of the latest work, which is actually quite convenient.
But you're going to have to be obviously prepared to deal with a lot more conflicts potentially.
Potentially, yes.
But if I'm hearing this right, you can
Yes.
you go to commit back to the master, you're actually forcing yourself to take on that earlier on.
Exactly, which makes it a lot more distributed and maintainable to handle that update. So, as I said, you are changing history by doing this. It is confusing for other people. If somebody else is trying to use your repository, all of their pushes and pulls will suddenly error out, saying, the history has changed, I don't know what to do. So, of the branch, yes. So best practice when changing history is only to do it in private. Once history has been made public to other people, if you think that other people might be using your branch, then it's confusing to them if you change the history of that branch. Any pull requests that people might make towards your branch will all of a sudden have tons of additional commits that seem to come from nowhere because the history has changed. And you never want to change history on master for a public project for exactly that reason. Lots of people are going to be looking at master. How you and your team decide to use the rebase feature, if at all, is up to you. But I would recommend that you only ever use rebase on feature branches that you don't expect other people to ever be looking at or using. And you inform people after you've modified history, because they can always use git reset to alter their branch pointers to reflect the new altered history. But you can only do that if you know that you need to run git reset to do that. The best thing to do, really, is to only use rebase to modify commits before you've ever pushed them to GitHub or GitLab or whatever you're using for your shared Git host system. Because then if you do that, there's no chance of anyone else getting confused. Nobody could have possibly seen your commits, and nobody would be bothered by history changing with them. But that's up to you. Personally, I will sometimes rebase branches that are on GitHub, but your mileage may vary. So after you've done a rebase, you do need to update the repository in certain other places, because you're going to end up with a situation like this, where your local repository is different from your remote repository. And if you try to do a git push with this, Git is going to tell you that's not something that we want to do. So in order to update this, you have to provide the -f flag to git push, or --force. A git push --force is one where you're telling Git, yes, I know history has changed. I want you to update the remote to reflect the changed history. Force pushing on Git can be dangerous if you have changed history in a way that you don't want and are losing information. Then you are telling the remote to also lose that information as well. And you can recover from it, because there are tools that will allow you to undo or change a rebase. But it's not so easy to do. As a result, lots of people are very wary about doing force pushes. In fact, there are some people who will say never do them at all, full stop. Those are the people who also say never change history once it's gotten on GitHub, ever, full stop. And I am not one of those people. So I encourage you to rebase responsibly.
And it handles everything. You don't say force this branch.
Well, you can. You can specify when you're pushing which branches and which remotes you want to push to. But again, because of the upstream thing, normally it's only going to push to the default remote. And when you say git push --force, it's going to know, okay, this branch that I'm pushing to this remote, I want you to update that. Anyone else? Okay. So once we're getting into changing history, then we can get into some really powerful stuff with interactive rebase.
Actually, just going back, if you do a bunch of branching, will you always have a force?
Not necessarily.
Is it only if you go back and
Rebase, yeah. You only have to force push if you are changing history. Because force push changes push from an append operation to an overwrite operation. An overwrite is more dangerous than append. If you're only appending, then there's no reason to do -force. So interactive rebase allows you to step through commits and perform operations on them, such as squashing multiple commits together editing a commit to separate it into smaller ones, inserting commits, deleting commits, reordering history. So I do this a lot to make it look like I am a perfect coder, and I have never introduced a typo ever. Because what I can do is I can make commits that fix typos, not what I wanted, make commits that fix typos, squash them all together into one, and then I have one commit that has no typos. And it's beautiful. You can also do that with commits that are too large. You can pull them out into smaller pieces. And if I had more time, I would show you how to do that, but I have less than 10 minutes left before noon.
And assuming you had a bunch of sequential commits, but if somebody else had interleaved commits in there, you could squash all of them, but you probably in practice would have to do that.
Yeah, you'd have to, for one thing, each commit can have only one author. So you would lose some of that authorship information.
Yeah, so you're effectively just compositing those down.
Exactly, yeah. And in some cases, that's a good thing because you didn't mean to make all those other commits.
And it looks like you've got a lot longer history than we intended.
Exactly. So you are, in fact, changing history because the reality is you committed a bunch of times. And when you're using rebase, you're actually changing that history to make it look like you committed only once. So some people will say, oh, you should change history to make it reflect what you intended to do. That's clearer. And some people will say, you should never change history. You should show what you actually did, because that makes it easier for people to debug problems when they come across them, to see what actually truly happened. Again, this is a debate. There are people on both sides of the fence. It's up to you to decide how you want to do that.
I could see it in a public institution where you're working on code that covers student finances,
Mm-hmm.
and you have an auditor hanging over your shoulder that will never do this.
Yes, yes. So whether and how to rebase is a question that you and your team should decide. There are good reasons to do so. There are bad reasons to do so. I also want to bring up the ref log, because if you're doing rebase, you're going to love the ref log. The ref log shows you every commit that you've touched recently, regardless of where that commit is in Git's history. So for example, when we were using reset-hard to pop a commit off of a branch, that commit is no longer on the branch, but it is still present in the ref log. So you can run git reflog and you can see all the operations that you've done recently. Do I have an example of this? No, I don't. Should have put an example. Oh, well. So you'll be able to see every operation on every commit. You can see, for example, oh, I did 3 different checkouts to switch between 3 different branches. And before that, I did a rebase to squash a bunch of commits together. And before that, I did some more checkouts. And then before that, I did cherry pick to move commits around. This allows you to recover the commit hashes of commits that you otherwise wouldn't be able to recover. So if you are rebasing, you should know the ref log because it will save your ass, I guarantee it. It has saved my ass many times before. And again, if I had more time, I would show you, but I don't have more time. So these are the commands that we've learned for moving commits around: branch, reset, cherry pick, and rebase, which is the command for changing history. Any questions about any of these? This is all the commands we've learned in this tutorial.
Can I just reiterate that cherry pick, see if I understand it correctly? So your workflow will be like you check out branch B and you cherry pick a commit in branch A, and then it will just be appended to the end of branch B.
Mm-hmm. Exactly.
Can branch starts with a detached head?
Yes, it can. So she asked if a branch can start with a detached head. And conceptually, a detached head is a commit that does not have any branches pointing to it. So if you have a detached head, you can make a new branch and point it to that commit. and then it is no longer a detached head. Anyone else? All right, I have 3 minutes before noon. I have a bunch of miscellaneous tools, but I think I'm just going to skip that and take questions from anyone else who has.
Don't we have till 12:20? The schedule says we're here till 12:20.
Do we? I thought that we were here until noon. I might be wrong. Oh.
Maybe I'm misreading the schedule.
Well, I am happy to continue going on with the presentation. I just don't want to keep you here longer than you want to be here. So how about this? Anybody who wants to leave, has plans to leave, has to leave, whatever, can just leave. I promise I won't take any sort of offense. And I will just continue on with the presentation as long as things go. How does that sound? Cool.
So if you've already merged a commit and it broke your app,
Mm-hmm.
what's the rollback?
So you could use rebase or reset to modify history and make it look like you had never added that commit. However, I don't recommend that because especially when you're doing things like a postmortem to try to figure out what happened here, you want to have the evidence of like, this is the actual change that happened. It's also gotten to the point where it's on master, which means it's on public history, so you're going to confuse people if you rebase. So that is a solution, but a bad solution. A better solution is to use git revert to do the opposite of, well, the inverse sort of cherry pick. Cherry pick takes a commit, makes a copy of it where you want it to go. Revert takes a commit, makes a copy of it with the contents reversed. So every line that was added gets removed, every line that was removed gets added.
So you would enter the half, git revert to a half, and then it would go there.
Yep. Well,
Instantly set it to the master.
no, you're not modifying branch pointers. This is like cherry pick. With cherry pick, you run git cherry pick followed by a hash, and it finds the hash, looks up the commit, makes a copy of that commit, and puts that copy where you are right now. So with revert, it's the same basic thing. You say git revert followed by a hash, looks up that hash, gets the commit, finds the contents of that commit, inverts the contents of that commit, makes a new commit with the inverted contents, and drops that where you are right now. Does that make sense?
Does that come with the same risks that a rebase does?
Well, not really, because you're not modifying history, you're adding a new commit on top of the existing history. You're appending to the history. Now, one possible risk that you might have is you do run the risk of conflicts, just like you run the risk of conflicts when doing a merge or when doing a cherry pick. If the commit that you are trying to cherry pick or trying to revert doesn't apply cleanly on top of the code base that you have at this point in time, then Git will say, I tried to do this, I got conflicts, you have to resolve the conflicts before I can continue. But that might be what you want. You know, if the bug that you got was due to an unresolved conflict, then you're probably going to have to resolve it again correctly in order to revert it. But that's sort of like a way of validating that this is actually the real situation, that you're correct, that it's a conflict. Does that make sense? Any other questions? Okay. I am going to keep on keeping on, and anybody who wants to leave is welcome to. Miscellaneous tools, everything you didn't know you couldn't live without. Git tag. Tags are a lot like branches, except that they don't move. So with branches, every time you add a new commit to a branch, the branch pointer automatically moves to point to that new commit. Tags don't move. That is effectively the only difference between branches and tags in Git. They're mostly useful for historical references, for things that can't ever change, such as the version of your code that was deployed to the website or that shipped. Yeah. I mean, they are labels, just like branches are labels. But the only difference is branch labels move and tag labels don't. That's all.
So is there sometimes people use tags instead
If you want to. In fact, actually, there are two different types of tags in Git. There's lightweight tags and there's annotated tags, as I mentioned here. So with a lightweight tag, it's literally just a name that points to a commit, just as with a branch. With an annotated tag, it creates a tag object in Git. And that tag object points to a commit, but also allows you to type in notes saying, this is the commit that was deployed to this version of our code base that went to this particular customer, and then we ran into this problem and had to roll it back. So you can annotate your tags however you'd like. But the thing about tags is once you make a tag, you cannot change it. Tags are designed to be fixed. And there are operations where you can delete a tag from a repository, but you should be careful with that because every time you do a push or a pull, the tags go with that push and pull. So once you've pushed a tag to, let's say, GitHub, if you try to delete it locally, you can delete it locally, but every time you pull from GitHub, that tag will reappear. So tags are really designed to be fixed. And once you get them into a code base, they are really hard to eradicate. That's by design.
Can you change the annotation of the tag?
That is also fixed. Yeah. Really hard to change by design. You can have multiple tags that all point to the same commit. That's fine. But you cannot edit a tag once it's been made public. And similar to like a virus replicating, once you let it loose on the wider world, you don't know where it's going to go. So be careful about those things. There's a company that I worked for that has a tag called release that we made like 2 or 3 years ago. Somebody was supposed to do a tag that had release followed by the date of the release, and they didn't. They just called it release. And that tag got out into the wilds, and it keeps on replicating and coming back, and every single release cycle we have to check for that tag and delete it, and it's really aggravating. So be careful with tags.
These show up in the GitHub UI?
Yes, they do. Mm-hmm. There's a separate section for them, just like there's a branches section and there's a tags section. Any other questions about tags? Cool. Git blame. Blame is a fun one. So as I mentioned earlier, Git treats the atomic unit of any change set as a file. Sorry, not a file, a line in a file. That's why the diffs, when you modify a line, it always says, plus the new version minus the old version, because it can't go any smaller than a line. What git blame will do is you pass it a file in your repository, and it will print out that entire file, and for every line of the file, it will tell you who was the last person to modify that file line, and what commit it happened, and when it happened. Yeah, sort of. So it allows you to figure out, oh no, this broke on production, and we're getting an exception on line 37 of this file. Quick, run git blame on that file, see who it was that modified line 37, so we can talk to them and get them to fix it. And not blame them, but blame the situation that caused this to get into production. Some people like making an alias in Git and creating a command called git praise that does the same thing as git blame, because a lot of people really don't like the connotations of the word blame. Sure. So this will only show you who was the last person to modify a given line, but if you want to get around that, you can check out the version where they modified that line and run it again, and it'll tell you the person who was the last to modify the line at that version, which is then the second to last person to modify it today. And you can keep on doing that to go back in time and see, okay, who was the person who modified this line, 5 months ago or whatever. Git blame is super handy when something breaks and you need to figure out who to talk to get it fixed. Bisect is also super, super handy. Bisect will help you find which commit introduced a breakage or a bug. And it'll do that using binary search to quickly find the commit instead of having to check every single commit So you need three things: a working commit, a broken commit, and a test to determine whether that commit is broken or not. You tell it that you're starting bisect mode, you check out the broken commit, and you say, this commit is bad, it's broken. You check out the working commit, and you say, this commit is good. And conceptually, what bisect is going to do is it's going to find the commit that is right in between those two commits that you have specified. And it's going to ask you, the developer, is this commit good or bad? Is it working or is it broken? If it's broken, then you can chop off 50% of the commits, and it's going to test in the middle of the area that's unknown.
And when you say in the middle, you're talking about in absolute number or
In absolute number. In absolute number of commits.
So back to your earlier example, somebody made a lot of typos and fixed it.
Mhm.
It's really not the bisection of the net change in code base.
Yeah. So in that is a case where having lots and lots of small commits is a good thing, because it means that it's easier to find the source of the bug if you have a small commit. So if this is broken, you test between broken and working. If this is working, you test between broken and working, and you keep on going until you find the commit that caused the breakage. And it happens remarkably quickly. And especially if you have an automated test, you can make it do this automatically. So bisect is an amazingly useful tool when you're trying to figure out how and why something broke.
So will it keep running that shell script in the binary search?
Mm-hmm. Yep. Yeah. So it just keeps on going in a loop. Check out a commit, run the script to test it, determine if it's good or bad, chop off half of the commits that it could be, and binary search the other half. Do it recursively until you find the one commit where it changed. It's really nice.
So it uses the exit code of the...
Yes. And I believe exit code 0 is success, and any other exit code is failure, except if your script exits status 255, which is an indicator that this particular commit could not be tested, and try another commit. Which is sort of an interesting inclusion, but I like it. Hook scripts. So somebody asked me earlier about a regex to check a commit message before it was done. So in the .git directory, we not only have that config file, we also have a hooks directory that has scripts that Git will run automatically based on the name. So you can have, for example, a pre-commit hook that every time you try to commit, Git will run this script, and if the return code is 0, it will allow you to commit. If the return code is non-zero, it will say, oops, and it won't allow you to commit. And you can output error messages from your hook script as well. And there's actually a framework that Yelp has put together at precommit.com for writing and maintaining these hook scripts, which I have never used precommit.com, but it looks really handy. So I would recommend checking that out. And you can also use these hook scripts to determine if you want to accept commits from other people or reject them based on the contents of those commits, if you're doing direct repo to repo pushes rather than going through something like GitHub or something like that. Git add by patch. I like this one too. We've already talked about why it's sometimes useful to be able to add files before running git commit. If you are accidentally, doing multiple different pieces of work, you need to fix a bug in order to add a feature, and so on. However, git add normally allows you to specify a file, and that's all. You can't go more granular than that. Well, if you use the -p flag, P for patch, then it'll interactively ask you every single change that you have made in that file. Should this change go into the staging area or not? So for example, if you have 2 changes in a file, one of which is fixing a typo in a comment, and another of which is fixing an actual bug, you might want to use git add -p to separate those 2 things into 2 separate commits. Because as we've talked about, having many smaller commits is often better than having fewer large commits. If you're doing something like bisect to try to find the commit where something broke, having a small commit is a lot better. So you might want to use git add-p to say, here's one commit where I updated this comment to spell it correctly. Here's a second commit where I fixed this bug that was actually in the code of the function. You have to pass some sort of file, right? So period refers to current directory. Exactly, yeah. I usually use period to indicate, just go through all the files in the repository and, show me all the changes one at a time and break them down. But you can do whatever file or files you want. So yeah, that was just me trying to make this a single one-liner command rather than trying to make you figure out what you need to put in the reference.
Do you use a file glob instead of a dot?
Yep. I believe that the way that works is the file glob is going to be interpreted by your shell before it gets passed to the git command. So git itself doesn't know how to deal with file globs, but in real terms, when you're sitting at the terminal and typing, it should work just fine, I believe. All right. GitHub pull requests. So this was that second line that we saw in the .git/config file when we were playing around with remotes. There's a fetch line. And that fetch line is designed to help format the reference that you make to a branch or a tag or whatever on a remote. If you add this line to your .git/config for your GitHub remote, that allows you to check out pull requests based on their number, rather than based on the name of the branch that the remote is sending to you, which is really, really handy when you're trying to review a lot of pull requests. There's also a tool called Hub, which allows you to teach Git about GitHub. And that allows you to, for example, run git create to create your local repository on github.com and set up the remote between them. Or, I didn't modify this slide entirely. I copied it from the previous one. Sorry about that. But that gives you a bunch of nifty Git commands, like git pull request, which allows you to take your current branch that you're on and use the GitHub API to make a pull request directly from your terminal, rather than having to go to github.com in your browser and do it that way. So this Hub tool allows you to do GitHub-related tools, GitHub-related actions from your command line. Excuse me. All right, and that is everything in my presentation. There's a lot of stuff that Git can do. It's made up of a lot of little tiny tools that are fairly simple individually, but taken all together have a lot of power. So there's a lot more out there that you can learn. And I'm happy to take further questions.
Can you force the garbage collector?
Yep, I believe it's git space GC for garbage collect. Oh, yes. That is on speaker deck already. Not advanced Git. That's a different one. Get started with Git. Yeah. So the slides are here. speakerdeck.com/singingwolfboy/get started with Git. I need to actually update that final slide in the presentation to make it correct. But that's all there. That is smart. And the last thing I'll say is my personal website is davidbaumgold.com, and there's a section on the left side for the book that I'm writing. And if you are interested in getting notified when this book is available to be sold, then you can put in your email address and subscribe to the mailing list. So, yeah, thank you all for coming.